Hi, my name is Steinkrauss and I work for Unified Automation. We are doing software development kits for OPC UA client and server development. Today I want to talk about the scan rate versus publish rate and why we need it and how to optimize the settings for those. First of all, whenever doing data acquisition, the dilemma is that we have different use cases and different requirements that we need to fulfill. And one is for control applications and analytics. We typically need a constant stream of data or time series of data that we call raw data. Then we have the HMI SCADA that typically wants to have the latest only for quick reaction. And then we have dashboard applications that are interested in changes only or maybe threshold only to present the data to an end user. And furthermore, we have the database, which typically needs a consistent set of data or triggered data at a certain point in time or for a certain value. And that's what's called a data set that you need for recording. And all these use cases can be fulfilled with OPC UA. And as you know, OPC UA data flow goes from the server to the client, and the client is a data consumer and the server is a data provider. And the communication between when the data flows from the server to the client, and that's what we call the publish. And the scan is the communication between the data source and the server. And there can be an event source or a data source or both inside the server. And typically it's inside the server because the OPC server is directly on the device that is having the data. And now what typically happens is that you have the request from the client coming in, requested scan rate and requested publish rate, and the server is answering with a revised scan rate and revised publish rate. And that's important because the revised value is that what's really happening. After that, the client will send the publish token, and then the server will send all the data that has changed in the publish response. This is why the arrow is a little bit bigger, because that's the large message with all the data contained. And then the client is sending again a token, and the server is sending again a publish if the data has changed, and whenever received by the client, sending a new token. And then we are in this kind of ping pong mode with request and response in a publish. And the publish rate and the scan rate, that's what is defined by the server, and it's for protection of overloading the source. And we look into details now. So as you know from the Nyquist-Shannon theorem for signal reconstruction, you need to scan the data with twice the speed and of the frequency. And of course, this may cause some load in the server. The publish causes load on the traffic, so it's important for the bandwidth. It's the network traffic. And as you can see on the left, I'm scanning or sampling the data at quite low speed, and the publish is even slower. And then you're detecting the change. So the green, that's the original signal, and the red is the replication of it. And on the right side, you can see if I sample the data faster and even have faster publishes, then I'm pretty close to the original signal when reconstructing it. And so this always happens if you scan the data. Another point you need to consider is that the two loops of the scan rate and the publish rate are probably unsynchronized. So if there is inaccuracy in the timing loop, then sometimes it may happen that you scan the data, you just get the new value, but unfortunately the publish is just going away a few milliseconds before, and you need to wait for the next one. So this is all about the timer accuracy. The server implementation on that side we call the sampling engine. Its implementation is server specific. So different servers can be implemented different. So you have an event source or an in-memory source. Typically an in-memory source is pulled by the server internally because it's in memory anyway. And the event source is firing the event directly. All this is what we call the sampling engine. You need to consider that some servers may have an external source, and that means that there is maybe another protocol involved that is beneath the server to the final device that has the data. And there, of course, it's also important, depending on the external source, if it needs to be pulled or if it can event-driven send the data to the server. And the good thing is we have two timestamps, the source timestamp and the server timestamp, in order to figure out where the data was created at what point in time. And this we can use also for the short signal detection. Because if we have a very short signal here in green and we scan it, as you can see it on the left, that it may happen that we miss the data. So we missed the first one here in our scan rate. We scanned the data and it was 0. And the second one we scan it again and it's again 0. And the peak in the middle we have not detected. However, the second 0 that is coming, that has a different timestamp. So if we subscribe for the notification not only for the value or status but also for timestamp, then we will get this information with this timestamp. And another option is the event-driven source, where we have a scan rate of typically 0 to activate that. And then whenever the data is changed in the source, then the source is notifying already the server, and the server is then packing that into the publish response and sending it to the client. And then we have replicated the information again, including, of course, the preservation of the original timestamp at the source. Now you can test that out using UA Expert, a tool you maybe already know. Here I have a simulation server connected, and on the left I drag and drop my byte here for reporting into the data access view. Then it's subscribed for reporting mode, and here I can see the published values coming in, including the timestamp. In this case, source temp and server timestamp is identical because it's a simulation server. And it owns its own data. If you right-click on the item, then you can, per each item, request a different sampling interval. And then you need to look here at the bottom into the log window. What about the revised sampling interval that the server is returning, because that's what's really going to happen. And another hint here, you have this refresh icon here. You can directly read the attributes. So that's then outside of the subscription mechanism of OPC. It's just an ad hoc read of all the attributes, including the value attribute, and of course the timestamps, both timestamps plus the status code. Another good example of these features can be seen with the data logger view in UA Expert. Here I have also drag and drop the same item here, the dynamic byte, which is incremented all the time. And I have a publish interval of 1000 milliseconds, 1 second. And I'm getting 412 samples, which I receive in 26 publishes. And this is because the sampling rate is 0, so I'm sampling fast as possible. And I have configured a queue with a length of 20 values. So I can queue up to 20 values, and I know that the data is moving in 50 milliseconds, so they will all fit in here. And then I get the block of data, the queue of data all together in the publish every second. So I have a better ratio on the network because it's not so much overhead. But I'm still getting all the values without any data loss. And I've selected the simulation activation item here so that on the right side I can write to the value true or false to start and stop the simulation. And if you stop the simulation here, then the value will not change anymore, so it will be frozen. And then of course the data is not changing. And what happens here, you can see that after 5 seconds I get the keep alive, which is also a publish message, but without any data. It's just an empty publish saying keep alive, which I get when the data is silent. And so I have still the control that the server is alive, it just has no data to send. So this is my summary on this topic. OPC UA has mechanisms for different use cases, and the scan rate and the publish rate needs to be considered. And when scan rate, you always need to think about load, and on publish rate, you always need to think about traffic. And if you want to preserve bandwidth, of course, also it's important for cost if you have to pay by traffic. For example, on a satellite connection, or if you push data into a cloud where you need to pay the cloud by traffic, then this is important. And you can optimize the overhead to payload ratio if you send queued, bulked data. So thank you very much for listening.